So just to check, is my screen viewable and my voice is audible?
Yes, sir.
Thank you. Welcome students to session number 15 of our ongoing course on electrical vehicles. And today we would be discussing on a very important component, that is the motors. Okay, so we have discussed upon the controller, the brain of the vehicle. Then we have discussed on the battery. Last two sessions were on the battery, the very critical item. And now we will be discussing on the motor. So just to give an idea of the motors, like what are motors? So motors, if we go by definition, motors they converts the electrical energy into the mechanical energy. Okay, so if we talk about all the processes that happens in the world, okay, whether it is linear motion or rotary motion or any kind of motion there, except the hydraulics, everything is done with the help of the motors only. So the entire industrialization, any kind of process industry, if you talk about, they are based on motors. They are controlled by the motors. Okay, so maybe like some processes might need higher rotation of the motors, some might need very precision motors. So accordingly the controlling of the motors would be there. So if we feel that the process, if some RPM here and there doesn't make many differences, then we can have a appropriate pulley ratio and we can manage that process. And if we feel that even few RPMs, 4 or 5 RPMs here and there of the motor can make a hell lot of difference, then what we do is we maintain sophisticated controlling devices which maintain the speed of the motor very precisely. Okay, so motors, if you talk about, they are like very energy efficient, and their efficiency, if you talk about, are in the range of 85 to 90%. So if you talk about the mobility also, presently the mobility, all are based on out of ICE vehicles. Mostly contribution comes from the ICE vehicles, and if that is replaced by the motors, we can achieve a huge amount of efficiencies. Okay, so if you talk about a normal ICE, the best of the ICE engine would be giving us a efficiency of 25 to 30%, which would be on degrading basis. From time to time it would be degrading. Okay, but if you talk about the motors, they would be giving us a constant efficiency. With some overhaulics from time to time, we can maintain this 85 to 90% of efficiency. So we can imagine that like efficiency wise, how much incremental efficiency we could achieve with the help of the electrical motor, or by using the electrical vehicles, to be very precise. So we are reducing the moving parts in the vehicle, and at the same time, like, we are achieving this incremental 2 times incremental efficiency with the help of the motors. Okay, so if it can be the motors, as we all know, can be controlled very efficiently through different mediums, through electronic circuits, or say some resistive, or different processes. In different processes, the controlling can be different. Okay, if you talk about our case, in the electrical vehicle, they are normally done through electronic circuits. They are in 2-wheelers and 3-wheelers, as we have discussed, we use controllers. And if we go for 4-wheelers, generally we use the VFDs, or the variable frequency drives. So contents that we would be discussing are history of electrical motors, types of motor, AC motor and its types, some important types of motors, types of motors used in EVs, comparison between hub and mid-drive motor. Okay, so if we talk about an electrical vehicle, it's either a 2-wheeler, 3-wheeler, 4-wheeler, or bigger commercial vehicles, or bigger passenger vehicles like bus. What we are at the end, what we are doing, if we consider the vehicle in a very raw form, we want to drive the motor through which the vehicle would be running, and this is like very raw, without breaking everything. The main motive is to drive the electrical vehicle with the help of the motor. Okay, so after that, second step is we control this movement efficiently. So ultimately, everything what we are doing, what is causing the motion in the chief component that is causing the motion in the vehicle is the motor. And for powering this motor, we are using battery, and for controlling, we are using controller and other electronic circuits we are using. So everything relies on a motor. So we can see how critical or how important this component of an electrical vehicle is. So as we have discussed from the very beginning, that this is one of the primary component of an electrical vehicle, the chief being motor, controller, and battery. So it is one of the most important components of the vehicle. So motion would be caused by it, and all our efforts, other efforts, if we talk about, will be concentrated on powering this electrical motor and controlling this electrical motor. Okay. So in that, use might be different in different kind of vehicles, type of motors might be different depending upon the space available in the vehicle, and depending upon the efficiency we need to achieve, or the source of electricity that is available to us, and definitely according to the pricing. And we would be using different kinds of motor. Their placement might be different at in different vehicles, and their type might be different. So history of electrical vehicles. In the very second session, we spoke about, when we were speaking about the history of electrical vehicles, there also we have shown this picture. So it was initially just to demonstrate the principle of construction of an electrical motor. So this was one of the first electrical motor built by Jadling in Hungary in 1828. So what he tried to show that how we can create motion using the magnetic power, how we can construct something through which we can do some useful work. The motion we can utilize in doing some useful work. So this was kind of a demonstration, and we can call it, it was a prototype for a modern motor. These were some how motor in its raw form, or in its very initial avatar, how the motors look like. Now they have evolved, and you could see how precise the motors have become, and they have a proper enclosure. And so these were the very beginning how design of the motor came into being. Initially, how they came up with the concept of the motor. So Thomas Davenport of Vermont invented the first official battery powered electric motor in 1834. So this was powered by electrical motor, battery. So it becomes definitely special for us. Okay, in 1886, the first DC motor that could run at a constant speed under variable weight was produced. So this is ultimately the concept of a motor. So this, normally in the processes, if we see, so the motor speed, the motor, our main focus is on keeping the speed of the motor constant. Okay, so at times that might be happening that the loading of the motor might be varying. So at times the loading might be different. So if you talk about electrical vehicles, say if there are gradient increase, then the loading on the motor will be different, because if a vehicle is moving, the weight can't change. Okay, so what can be changed? See, some dynamic aerodynamic forces could change because of heavy wind blowing across you, or the gradient. Suddenly the gradient might change of the road, that could create pressure on the vehicle. The motor speed would tend to reduce. So in that condition, the motor should be should be such that it attains the speed is not change. Okay, so we would be supplying some additional current, we would be supplying to maintain that speed. Okay, so that way an ideal motor is one which moves which even at the varying load also, it maintains a constant speed. So this was demonstrated in 1886. The first DC motor that could run at a constant speed under variable weight was produced. The second picture that you can see on your right, these are again some other the motors that were introduced. So in 1887, Nikola Tesla invented an AC induction motor and patented it a year later successfully. Okay, so this was the first patent motor that you could see in the first picture. Then General Electric came with the first three-phase AC induction motor in 1896. General Electric is known for the invention of the motor. Normally, if you see or if you study, then you will find that General Motor is invented. Modern motor that we see today was invented by General Motor in 1896. In the 21st century, both AC and DC motors are widely used in all industries across the globe, from automobiles to manufacturing. So if you talk about 21st century, the entire industry, as I spoke about, whatever the process, the manufacturing, or whatever kind of an industry, it would be using variable different kinds of motor depending upon the use. But whatever kind of the motion is, whether it is or a rotary motion, it would be contributed by the motor. So motors at the end of the day forms the backbone of the industry. So definitely we would be focusing all our studies on electrical vehicles only, but it should be known that motors are the backbone of industrialization. Anything uh, except, I said, as I said, the hydraulics, if you leave out in some processes, the everything, every type kind of motion and is applied at the is applied by motors. Energy generation happens through motors only. Alternators, they are synchronous motor. So most of the processes are dependent upon the motors, and they forms the backbone of industrialization or backbone of any process in the industry. 1888, the AC induction motor is patented. 1887, Nikola Tesla invented an AC induction motor and patented it a year later successfully. It wasn't suitable for road vehicles, but it was later adopted by Westinghouse engineers. So 1891, the development of three-phase motors, General Electric started developing three-phase induction motors. So still, even if you talk about the industry, 80% of the motor use are induction motor, because the power that we get is an AC source, and induction motors normally run on either single phase or three-phase AC power. So motors that you would see in the industry are normally induction motors, and the best benefit with induction motors are the speed controlling is much easier in comparison to other kinds of the motors, but their initial torque is not that high. So in order to have like induction motor, to have a process where you need very high where you would need like very high initial torque, where you need like if you have to introduce normally in a rotary motion, if you have to if you have to like rotate something like very bulk, which contains a lot of weight, or which is like very heavy, then you would need something like instead of electrical AC motors, induction motors, you would be requiring DC motors. So wherever there is initial high torque required, there we normally using DC motors. Whereas in other processes, we would be using a AC induction motor. Even if you talk about the industry, normally we use three-phase AC motors because they are self-starting. They don't need any like a single-phase AC motor. If you talk about, they are not self-starting. We have to have capacitors through which it is made self-starting, as you see in our fans and other electrical appliances. So in industry also, three-phase AC motors are generally used. So the 2000s use of motor today. So in the 21st century, AC and DC electric motor are now widely used in industry, from powered wheelchair to industrial automation, transport, and solar panels. So if you talk about like their various use and like how they have evolved the modern motors, then you could see that you find motor in each and everything. In any appliances you talk about, even if in the computer, if you talk about, you have like motors like added on the processor, there is a small motor. Then the cooling fan contains a motor. The laptop or the laptop that we are operating right now, on our head we are using a fan which contains a motor. Air conditioning, if you are using, there also we have a motor. So normally in every electrical appliances we would require a motor. Then other again for pumping water, and so any use you see in like in our normal activities of also, if you see, then you will see a lot of like motors being used here and there. Okay, so these as an example, like they have given like various forms of the motors that were invented or came into being at different stages in different centuries. So 1905 first motor, 1960 DC motor speed control. So speed control DC motor was introduced. Then 1980s BLDC gear motors was introduced. In 1999, inverter duty gear motors, AC three-phase motor was introduced. Okay, inverter duty gear motors, AC three-phase was introduced. Then Integra motor 34B SRWX, that was introduced. And in 2017, planetary gear motor BLDC and permanent magnet DC motor was introduced. In 2020, hazardous locations C1 D1 and C1 or oblique D1 in places of hazardous location, for them the motor was invented. So if it see, like, motor has a variety of use, whatever kind of situation there is in the industry. So you would find a motor depending upon the, like, even they can sustain high heat. Secondly, they can continuously run. There are processes which runs for 24 hours, 24/7 they run. So the motors would be running for say weeks. Only before they are taken for overhauling, they would be running continuously. So the motors are very like a robust component even in the industry you speak about. So they are very robust, and they have to be, and they are manufactured, or they are designed in such a way that they can take care of the processes or the temperature requirements at the place they are installed. So broadly classification, electrical motors are normally classified as DC motor, AC motor, and brushless DC motor. Okay, so DC motor, again DC shunt motor, separately excited motor, and these are the categorization are based upon the starting how the motors can be started. Depending upon them, they're categorized into DC shunt motor and separately excited motor. AC motor, if you talk about, synchronous motor is there and asynchronous motor is there. So synchronous motor, we know that the motors that run on the same speed, we call them synchronous motor. In synchronous motor, we have two varieties like permanent magnet synchronous motor and synchronous regular motor. If we talk about asynchronous motor, if you talk about, then we there are induction motors. So induction motor can be then single phase it could be, or it could be three phase, depending upon the use. So these are the broad classification of the motors. So the general classification, these are the general classification of the motor. So DC motor, a DC motor or direct current motor is an electrical machine that transforms electrical energy into mechanical energy by creating a magnetic field that is powered by direct current. So motor, as we have spoken earlier, only it is a device that converts the electrical energy into mechanical energy, okay, to run a process or to run a machine or to run a prime mover, so that net work can be done at another end. So that is the use of the motor. Or how you power the motor, depending upon the type of the motor, we would either power it through a DC source or we would power it through a AC source. So if you talk about DC source, it would be powered by a DC source. Okay. So here first is the shunt wound motor. So this is the most common type of DC motor. Here the field winding is connected in parallel with the armature as shown. So in this there would be a field winding in parallel to the motor armature. So this is the first kind of motor, that is a shunt wound motor. Separately excited DC motor, as the name signifies, the field coil or field windings are energized by separate DC source as shown in the circuit diagram shown below. So in first case we show we have seen that a same supply is applied across the armature and the field winding. But in case of separately excited motor, if you see, then the field winding of the motor, that would be given a separate supply. Okay, separate supply would be given to the field winding, due to which an electromagnetic field would be generated, and then this motor would start moving, and through which it would be connected to an prime mover, through which output would be obtained. On that prime mover would be connected to some pump or some other appliances for movement. So AC motors and its type. Synchronous motor, the motor that converts the AC electrical power into mechanical power, is operated only at the synchronous speed and is known as a synchronous motor. So if you talk about a synchronous motor, they run at a particular same speed they run it. Okay, so they run at a same speed, and generally synchronous motor are normally used for the generation of the power, that the alternators that are installed in our powerhouses, they are generally synchronous type of motors. When supply is given to a synchronous motor, revolving field is set up. This field tries to drag the motor with it, but could not do so because of rotary inertia. Hence, no starting torque is produced. Thus, an inherent synchronous motor is not a self-starting motor. As we said that there are some motors which are not self-starting. So same is the case with the synchronous motor. They are not self-starting. We have to give initial, we have to create a rotation so that uh, when the poles are separated, it starts running. Otherwise, when we power this, it is not a self-starting motor. Okay. So the movement can be done with the help of initial movement can be done with the help of a generator or with the help of some source of energy through which we can start the movement, and then it could be removed, it could be separated, and then the synchronous motor can run on its own. So if we talk about there are two types, either PMSM or permanent magnet synchronous motor or synchronous reluctance motor. These are the two types of the motor that are available. So this would be dependent upon the type of the magnets or the type of the field in which the rotor would be moving. It would be either differentiated into a permanent magnet synchronous motor or synchronous reluctance motor. So here you can see the outer body of the motor is called the outer motor, that is the stationary part of the motor is called the stator, and the part of the motor which moves is called the rotor. And there would be like if it is not a permanent magnet, if it is not a permanent magnet motor, then this electromagnets would be generated when we give a power. Then electromagnets would be will be formed, and they would be repelling the north and the south pole for the motion of the motor. Induction motor or asynchronous motor. So in an induction machine, the armature winding serves as both the armature winding and the field winding. When the stator windings are connected to an AC supply, flux is produced in the air gap. The flux rotates at a fixed speed called synchronous speed. This rotating flux induces voltage in the stator and rotor winding. Current flows through the rotor winding and reacts with the rotated flux, and torque is produced in the steady state. The rotor rotates at a speed very close to synchronous speed. So if you talk about an induction motor, the induction motor is the one which doesn't run at its at a synchronous speed. It doesn't run. So there is always there is every motor comes with a particular RPM. Okay, so that won't be that would be lesser than the synchronous RPM. Okay. So generally this normal induction motor, if you talk about, they won't be available in the RPM won't be synchronous RPM. As we know that how we calculate the synchronous speed of a motor, it is like 2f divided by the 2 into frequency divided by the number of the poles, so that we get the frequency, we get the RPM of a motor. So in case of induction motor, the RPM is lesser than the RPM speed. So if we talk about a general induction motor, if we talk about, then it would be not coming on the if it is a 4-pole motor, then it won't be coming in 1500 RPM, but it would be coming around something around say 1440 or 1450 RPM only we would be getting. Okay. So this also consists of a stator and a rotor. We have a stator windings which are energized with a source, single phase, 2-phase, 3-phase, depending upon the type of the source. Then this source will be creating a field, rotating field. So air gap, what is the air gap? When you assemble the motor, the left out space between the rotor and the stator, very thin space is left out, and that would be called as the air gap, and the rotor would be moving in that only. So precisely if we speak about it, is like in very small gauges, it is like we can through naked eyes we would feel that no, there is no gap between the two, but there is a small gap is maintained, and this gap has to be kept as small as possible so that the losses are small. Okay, so when we power this windings with the source of electricity, then this rotating field is generated, which helps in movement of the rotor. Okay. So if we connect if we connect if this rotor is connected with a prime mover, and then with some machine, if it is connected, then as we know that with the movement of the machine, the machine will try to reduce the speed of the motor. Okay, so to keep on supplying the constant torque to the motor, it would be drawing some electricity from the source, and to like to maintain the constant speed, it would be supplying the electricity in such a way that it maintains the constant speed of the motor. Okay. So if we talk about other types of motor, so there are two types of hub motors: geared hub motor and gearless hub motor. Internal planetary gears to reduce the speed of a higher RPM motor, and gearless motor, no gearing and direct connected to the lower RPM motor stator axle to the bike. Rear hub motors are predominantly used in the global hub motor market. So if you talk about if you talk about hub motors, there are some like geared hub motors. So they could be like there could be some physical gears could be there. Okay, so through which we could like reduce or increase the speed. Normally that comes in only in three wheelers, because in two wheelers that is not possible, depending upon the space constraint. It is not possible in two wheelers, but definitely in three wheelers we have physical gears through which you can like vary the speed. You can change the gear ratio, and you can vary the speed. But there are, as we spoke earlier, also there are electronic gears through which there are different modes through which you can set the speed limit, so that if you set a certain speed limit, then the speed of the motor won't be exceeding that. So that could be done electronically, that could be done. And as we call it, gearless hub motors, as we so this can be done electronically. This could be done, and there in bigger vehicles, in three wheelers, we can have a provision of gear also. So mechanically also we can set the gear ratio to maintain the speed. So if you talk about hub motor, if you talk about, since it is directly fitted into the hub of the electrical vehicles and there is no transmission media involved, so we can get like powerful acceleration and better traction and high flexibility, and like high torque, very high initial torque we can face, because there are no losses in the losses or in the power transmission, because it's a direct transmission. No medium is involved, neither a belt or a chain is involved in this. Higher power can be handled better in the rear wheel of the e-bike. So as we know, it has to be installed in the rear wheels. Now you must have seen some models who are claiming to be hybrid models. What they are doing, they are installing the hub motor in the front tire of the vehicles, in the front tire of the two wheelers, and they are saying that it is a hybrid vehicle, it can run on petrol uh, and on electricity. But that is not a good thing to do, because what happens is if it is installed in your rear hub, it would be a kind of a push, and if it is installed in the like in the front wheels, it would be a pull. So your chassis alteration has to be done that way. And at the same time, if you are on a speed, like if you want to take a turn, it is not possible if you are running on the motor, and if it is in the if it is in the front wheel. So always the driving wheel is the rear wheel, so that you can properly take turns at like whenever you need to take turns, you can easily take turns safely, you can take turns. So it is advisable always to use a hub motor on the on it is advisable to use the to fit the hub motor on the rear wheel. So like this is one of the motor that we have used for one of our re-engineered vehicle. So it is like very much our own product that we have used. The motor, we have not produced it, but our product, that is the re-engineered vehicle, is fitted with this motor. So this is a hub motor. So like to explain you, like this is the stator and this is the rotor. Okay, so when this is assembled, this portion, the tire will be mounted on this rim. It would be mounted on this rim, and this would move. So this rotor, if you talk about, this consists of a lot of magnets, 60 around 64, if I be very precise with this motor. It contains around 64 magnets, flat magnets it contains. Powerful flat magnets, rare earth, niobium magnets are installed over here. Okay, they are fitted over here. Okay, and in opposite polarity. So if one magnet is north pole south pole, then it will be south pole north pole. So all in opposite polarity, they are installed over here on the rotor. And this is the stator part. Okay, so this is the stator part. You can see the windings over here. So these are trapezoidal three wire windings have been done. Okay, so and this is like the typical we have used these are the sensor Hall effect sensors. Okay, so why do we use Hall effect sensors? So say like I have to drive my motor, but there has to be some communication with the controller and the motor. So at what time, what decision has to be taken? Okay, so that decision would be normally the communication between the controller and the motor. So it can't be just a supplying device that it is giving a constant supply. It has to have an input also, like at what time, like how much voltage and current has to be given to the motor. So that communication between the controller and the motor is through these Hall effect sensors. Another very important thing that the Hall effect sensor do is you must have seen that in earlier DC motors we used to have, they were the brushed DC motors, we used to have a commutator. So what was the what was the main motive of the commutator was to keep the output in a single direction, so that we so that the constant DC is maintained. Okay, so that was the main function of the, so you can say it is an electronic commutator. So what does this Hall effect sensors do is, as I said, that these are three wire windings are installed in the stator. So we are using here permanent magnets. Okay, and the input power is also DC. So say if like initially the motor starts moving, so the field of these magnets, the permanent magnet is constant in the same direction. Okay, so this DC that is also flowing, if it keeps on flowing through a single wire, so after some time what will happen is this permanent magnet field and the field generated in the stator windings because of the DC input, they will tend to be they will tend to become parallel. Okay, in the same direction they will tend to after some after a rotation, a single rotation, they will tend to converge and become like parallel. So in that case the repulsion, the motor might come to a halt. So in order to avoid this situation, normally what we do is the energization, these three wires are energized like one at a time. So if say wire number one is being supplied the supplied electricity, then another instant second will be done, and in another instant third will be done. Okay, so that this alignment of permanent this field of the stator and the rotor are not aligned in a direction. They are at any point they are repelling each other. Okay, so that the the constant of motion of the motor maintains. Otherwise what will happen is the motor will come to halt after some time. So that should not happen. So we have to energize say A, B, C. If there are three wires, then we have to energize these wires one at a time. So in first instant one, in second instant two, in second third instant three. So this decision or this is done with the help of these Hall effect sensors that is being done. Okay, so for three wires we will have three Hall sensors installed on this plate. So general first only the function of the Hall effect sensor, as I said, that they are they senses the magnetic field, the intensity of the magnetic field and the direction of the magnetic field they senses, and accordingly they energizes, they help in energizing a coil at a time and interchanging the energy given to the coil. So first if A is energized, then in second instant B would be energized, in after that instant C would be energized, so that the net magnetic field is not zero at any point of time. They are repelling each other, they are in opposite direction, so that the motor keep on moving. So due to which so this use of Hall effect sensor is very critical if we have to maintain keep on if the motor has to be keep on moving. So say in a service case we see that our vehicle we are giving full throttle, but the vehicle is not moving. Okay, it's and the vehicle motor is not like constantly moving, and or it is jerking, cut 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 cut, it is jerking in giving that kind of sound. So that noise, so we should practically we should identify that there are issues with the Hall effect sensor, due to which the constant motion is not happening, or the motion is happening but at some instant is missing out, they are missing at some instance. So after two rotations, there would be the motor will stop, and then in third motion it will catch again, because in that during that movement, third that Hall effect sensor, the particular Hall effect sensor is not working, or not they are not the field they are not sensing, because of which there is a miss in one of the rotations. So whenever the motor is either jerking or it is continuously not moving, then we can know that yes, definitely there is an issue with the Hall effect sensor. So general Hall effect sensor work is to sense the intensity of the magnetic field, the direction of the magnetic field, and coordinate with the controller. So again, like hub motors, if we talk about hub motors, then the hub motors can be used either according to the position where they have been installed. We could either say that the hub motor is the vehicle is a mid-drive, it is a mid-drive motor, or it is a hub motor. So if you talk about a mid-drive motor, so they are installed in the middle of the vehicle at some other position, and the rear wheel is rotated via either the chain or the belt. It is rotated, so that we will call it as a mid-drive motor. So the modern vehicles that you are seeing, the Ola or the Uber or the other models that are coming, they are now mostly the vehicles are coming with the like mid-drive motors only. And if you talk about the important aspects or the advantages that the hub motor have, mid-drive motor have, then a mid-drive motor is so named because it is located near the bottom where the cranks are, the arms that holds the pedals. So typically in a cycle, if you see that you could see the position of the hub motor, it is installed there, and with the help of the chain, the rear wheel is rotated. The electronics required to coordinate the motor's power with pedaling and shifting are more complicated. Therefore, it is important to be the correct gear when riding a cycle with a mid-drive motor. Okay, so depending on the programming, the shifting and ride may not feel smooth. Like it is normally said about the bicycle, where you have a dual mode of operation, where you would be pedaling in between, and then again you would be moving on the battery also. But if you talk about electrical vehicles, it's normal. It doesn't create that much of issues because it is driven through with the help of the belt, and the pedals are not involved. So in bicycle, we could have these issues, like the sensing pedal movement, sensing the pedal movement in a proper gear ratio. So the gear ratio would be an issue when we are installing it for electrical bikes. When we are installing it, so we have to maintain a correct gear ratio, so that if we are re-engineering a vehicle, there also we have to see that we are opting for proper sprocket to maintain the gear ratio, so that it's not so that the desired speed we need initial. Actually, the issue with when we are installing the mid-drive motor, the best advantage that we get is that when initial the vehicle is starting, the torque is not transferred immediately, so you won't feel a jerk. Normally, if you witness some vehicles and you would see that the throttle of the electrical vehicles is more smoother than the normal conventional vehicle. So if you pull or if you twist the throttle more than required, then you would get a initial push, you get a thrust, okay, or a jerk you will get. So to avoid that, the mid-drive motors are better in managing that, because the power transmission is happening through a belt, or so they can dampen out the initial push or which you get when you start the electrical vehicle. So there they can manage that jerk that can be managed initially when you are starting the vehicle. The electronics required to coordinate the motor's power with pedaling and shifting are more complicated. So these are the normal disadvantages associated with the electrical bikes, where we have a dual mode of operation, either on the pedal or also on the electrical vehicles. There we can have some syncing issues. Otherwise, if you talk about a fully electrical vehicle, like electrical bike, if you talk about with mid-drive motor, we don't face much issues. So type of motors used in electrical vehicles. DC motors. So generally, if we talk about two-wheelers and three-wheelers, we mostly prefer using DC motors so that we can have a supply from a battery source, and the motor can run directly without any conversion. Okay, so we don't need any conversion. So, and since the space constraints are very high in case of two-wheelers and three-wheelers, so normally we use DC motor. So it takes direct power from the battery and then it runs. So depending upon their position, they could be either a hub motor or they could be mid-drive motor, but normally all DC motors we will be using. So DC brushed DC motors are one of the simplest type of DC motor. It uses brush to deliver current to the motor winding through mechanical commutation. So these motors suitable for many uses because of their low cost. Brushed DC motors are widely used in electrical vehicles for retracting position and extending electrically powered side windows. So DC motors, if you talk about, and if you talk about brushed electrical motors, if you talk brushed DC motors, if you talk about, so in modern electrical vehicles, in the primary use, their use is like we could call it negligible, or they are not preferred, or they are not being used. But brushed DC motors can be used in uh, other for other processes, like for power windows they can be used, and for other processes they could be used. But for primary purpose, we don't use DC brushed DC motor we don't use. So here you see that in DC motor we are using carbon brushes, okay, and a commutator is being used. So these carbon brushes, what they would do is they would keep on, as we have seen that the job that is done by the Hall effect sensor is normally done by the commutation over here, but it would be mechanically done. So the coil would be powered one at a time, and the next would be powered at another instant. So this has to be done so that the permanent magnet field and the field in the stator field developed due to the supply of the current doesn't align with each other. They are always repelling. So we would be using a commutator and carbon brushes over it. But these kind of motors require a lot of like maintenance, because after some time there would be like wear and these carbon brushes would be like losing. They would be keep on since they are always in contact with the commutator, so there would be continuously there would be in contact. So they have to be, from time to time they have to be replaced after they have lost majority of their portion, because there would be wear and tear across these carbon brushes. So we have to as a maintenance, we have to keep on changing them from time to time. And at the same time, this commutator, if these carbon brushes has weird unevenly, so there might be sparking on these on this commutator also, due to which at times it might happen that because of the carbon collection we are not able to supply power into the motor. So at that time we have to again this has to be properly maintained, and this has to be grinded properly so that it becomes even again. So these are some maintenance issues there are there with the DC motors. And next, as you can see that they are mechanically done, so their efficiency is also low and the reliability is also low, and the reaction time in in types of motor is also low. They would be used DC motors, brush DC motors we would be using, where the controlling is not that big and of a factor, where we need the controlling we might, if it is not fully even very precise, then also it can be done. So in those processes, in those kind of applications, we can use DC brushed DC motors we can use. So 775 DC motor installed in bicycle is the size. 775 is the size ID of motor. So here you can see a DC motor installed in this bike. So permanent magnet BLDC motors. So initially we have seen BLDC motors, and this is permanent magnet BLDC motors. So the general BLDC motors that we are seeing are permanent magnet BLDC motors. Permanent magnets these permanent magnets, rare earth magnets are installed on the rotor. They are installed. Okay. So what happens is they have their continuous field, a fixed field they have. Okay. And when we will putting this rotor into this and supplying electricity through these different three coils winding, if it is, if we are supplying through this winding, then the fixed field and this field generated because of the current flowing into the windings of the stator, they would be like repelling each other. So to keep this repulsion at any point of time, we have to energize one coil at a time. Okay, so that function would be normally done with the help of the Hall effect sensor that we would be using. So these magnets, if you talk about, these are permanent magnets, and they are placed in such a way that they have reverse polarity. So if it is north south, then it is south north. So that they are in opposite polarity. They are placed in such a way. They are always in even numbers, so that the poles are maintained. The brush and their maintenance are eliminated by moving the permanent magnet to the rotor and placing the electromagnets on the stator. Advantage are a long lifespan, low maintenance, and high efficiency. Disadvantage are high initial cost and more complicated motor speed controllers. This type of motor is popular for smaller vehicles like electrical bikes, scooters, etc. So normally in electrical bikes and two-wheelers or even the three-wheelers, if you see, normally we use the permanent magnet BLDC motors only we are using. Okay, so how better they are? They are better because they give a low maintenance. Only that it has a complicated speed control. So as we said that we have to have a Hall effect sensor, and accordingly we have to install it. The coordination has to be proper with the controller, so that so that at any point of time, like depending upon the situation, we can control the speed of the vehicle. So generally these are the mostly more widely used motor in the electrical two-wheelers, if you talk about. So they are such that if you can see this animation, if you see, so these the charging of the coil is changing, and so is the the rotor movement is as the rotor movement is happening, and this charging of the coil is changing at a time, so that there is always a repulsion maintained. Okay, north south is created in such a way that at any point of time there is repulsion happening with the among the two poles on the magnetic field of the permanent magnets, and on the magnet with the magnetic field of the winding installed on the stator. Electrical scooters using BLDC motors. So Ather Energy scooters are using BLDC motors, 22 motors. Then Hero Electrical is using BLDC moters. Then NIU electric scooters, they are using electrical BLDC motor. Electrical motors using BLDC motorbikes. So Torque and E-Motion, they are using BLDC motor. Cost of BLDC motor in India, cost of 900 watt BLDC motor starts with 2200. Cost of 1 kilowatt starts from rupees 2400. So these costs that we are giving, they are again depending upon the size of the motor. So if you talk about normal two-wheeler, a scooty type two-wheeler, they would be available in two sizes, either 10 inches or 12 inches. And if you talk about motorbikes, they would be in 18 inches and so on, depending upon the rear wheel of the bikes. Permanent magnet synchronous motor. So it can be seen as an AC counterpart of the brushless DC motor. Permanent magnet synchronous motor comprises a permanent magnet as a rotor and a stator with coil wound over it. The working of the permanent magnet synchronous motor is also quite similar to the BLDC motor. However, the change lies in the waveform of the back EMF, which is sinusoidal in nature. This is because the coils are wound on the stator in a sinusoidal manner. So depending upon the, again, it also contains permanent magnets on the rotor. The stator windings is such that the input that they receive is in the sinusoidal form. So in the BLDC that we have seen, they could be like even the square waveform, if is power is supplied to them, that also will be good for them. So controller would be different in case of permanent magnet BLDC motor and permanent magnet synchronous motor. So the precisely the input that is coming to them should be in the sinusoidal waveform only. then only they will be able to efficiently work. So this kind of motors, what they advantage they gives us are, if we are designing a bike where there are a high gradient, so there we would be using mostly this synchronous permanent magnet synchronous motor we would be using. So this would give us a better efficiency when we have to climb gradients, and at the same time the motion is much smoother in case of permanent magnet synchronous motor. So this shifting of the poles, or you can say the energizing of the coil, it is much smoother. So when we are even riding, we would see that this motion is much smoother in case of permanent magnet synchronous motor in comparison to BLDC motor. But they come with a catch that they are more expensive. They cannot be, they have to have a synced proper controller they need to have. So you cannot use any controller with in case of permanent magnet synchronous motor. You have to have a proper controller, a sine wave controller you need to have a properly matched with the motor, and then it has to be given in like motor controller set only, so that it is ready to fit to the vehicles. A bit expensive, but less noise free in comparison to BLDC motor. So these are some advantages. So high torque and better performance, high performance in both high and low speed of operations, more reliable and less noisy than other asynchronous motors. But the disadvantage is that it is a bit more expensive than the normal BLDC motor that we have spoken about. So however, the change lies in the waveform of the back EMF, which is sinusoidal in nature. This is because the coils are wound on the stator in a sinusoidal manner. So as we talk about the winding that we saw in case of BLDC motor, that was a trapezoidal winding, and in this case it is sinusoidal winding. So typically deassembled permanent magnet synchronous motor, if you see the so you can see that the magnets, then there are like steel plates, bearing support assembly is there, a rotor hub is there, then stator core is there, on which this bar wound wire is there. So this rotor core section is, so this winding can either be in the format of the bar, or they can be in the format of the normal coil only, depending upon the size and the capacity of the motor. These would be and the voltage rating of the motor, these would be either in the form of the bar or in the form of the coil. So that would completely dependent upon the capacity and the voltage rating of the motor. So what are the models that which are using permanent magnet synchronous motors? Energica motors, Brahmo Impulse R. Electric cars using permanent magnet synchronous motor is Chevy Bolt EV and Nissan Leaf EV. They are using permanent magnet synchronous motor they are using. Electric buses use permanent magnet synchronous motor. So buses also use permanent magnet synchronous motor. Tata Ultra Urban 6 or 6 feet or and 609 and 612, they are using this permanent magnet synchronous motor. Depending on the placement of the motor, it is future divided into interior permanent magnet or surface permanent magnet. So depending upon where we are placing it, so it would be either interior permanent magnet or surface permanent magnet motor. So induction motor, as we know that induction motor is a very wide use in the industry, and they are the most common type of the motor that are available. Very easy to, like, speed variation can be done very easily. So, and there are different formats for controlling their speed also. We can vary the voltage or we can vary the frequency to control their speed. So that is the advantages associated with the induction motor. The only disadvantage is that we have to have a AC supply to run these motors, to supply the power to them. So for that we will need we need a conversion stage we will need, so that from battery we are taking DC, it is converted into AC, and then we are powering the motor. So for use of the induction motor, what we it won't be possible for most of the vehicles which have space constraint. So two-wheelers and three-wheelers will not be able to accommodate the entire power. If you talk about the entire assembly and the entire components, if we talk about for the use of induction motor cannot be done in two-wheelers and three-wheelers, because there we have a space constraint, but it can easily be done in case of four-wheelers. And one thing that we have been discussing, that the DC format of the motors, are whether it is a permanent magnet DC motor or a permanent magnet synchronous motor, both are using strong electrical magnets. They are using rare earth electrical magnets they are using. So we know that the deposit of the electrical magnets is also very few countries. So we want to decrease the dependence on these magnets. Okay, so imports on these magnets. So using induction motor, it gives us that benefit, that it would be it would be produced in our country itself, because we are like masters in manufacturing induction motors, and indigenously we have been doing it. Even the controlling devices we have been using it, because since ages we have been using induction motor in the industry. So we have seen the entire life cycle of the motor. So they are, if we make use of induction motor, why we accept wide use of induction motor, then it would be easy that we are not dependent on other countries for the for the manufacturing of the motor. Because still, if we see that the DC motors that are manufactured in India, we have to be dependent on, for magnets we have to be dependent on other countries. Okay. So also one more thing, that for electrical vehicles, the energy density of the motor has to be very high. And for this, the permanent magnets that we are using, they have to have a like specific high energy density they have to have. And like high temperature withstanding capacity also they need to have. So that is only available with these rare earth magnets, the newbody magnets, and they have to be imported. So, and there also we have a limitation, that the energy density is also can be to only for a limited use. To at certain kilowatts only we can do it. Otherwise, after that, the overheating of the motor will start, and it would start losing its properties. So for larger vehicles which need like power in kilowatts, there the induction motor is more widely used. It is more popular in those kind of vehicles. So it consists of a rotor and a stator. The stator receives electric current input from the battery and rotating magnetic field set up around the stator. This induces the current into the rotor as well, which makes it rotate. The rotor is directly connected to the transmission, which is generally a single gear transmission setup. This directly causes the wheel to move. So depending upon the transmission, if it is a single gear transmission or it is a gearless, it is electronically driven, that can also be done. So what happens is, first the DC power received from the battery, that is converted into the AC three phase. If it is three phase, normally we use three phase induction motor because they are self-starting. That is fed into the VFDs, variable frequency drives, and through these VFDs we have a connection with the induction motor, which makes them move. Depending upon the VFDs or the vehicle control units that we call, they are the controllers of the four-wheelers. Okay, so through them the speed control would be done, and other controlling of the motor would be done with the help of these either VFD or through the vehicle control unit. It could be a consolidated unit like which would be having like VFD and other controlling. So we could either call it a VFD or we can call it a vehicle control unit for the controlling of the motor. So two-wheelers using induction motor, M-flux motors, M-flux 1. They might be using, but these are very rare, and it would be very like heavy bike, because the conversion step that we spoke about, we have to accommodate an inverter in between when we are using an induction motor. Four-wheelers, definitely we said that majority are using induction motor. Tesla Roadster, Tesla Model S, Tesla Model X, Mahindra Verito, Tata Tiago, all are using induction motor. So induction motor used in four-wheelers give us, first of all, it could be indigenously manufactured, so we don't have dependence on the other countries. Secondly, the controlling is like very easy. The speed control can be done in a variety of ways. Very precisely it could be done. Secondly, they are efficient. Comparison between hub and like mid drive. So in mid drive, like throttle mostly and no throttle usually. So there could be like they could be without throttle also they could be run powerful and less power. So hub motor initial power initially they are, since they are directly driving the vehicle, so they are more powerful, and in case of mid drive they are a bit less powerful. Low maintenance, mid drive, high maintenance because of the transmission system that they contain. Easy to ride and constant shifting required. So affordable and expensive. So these are some features, advantages, comparison between a hub motor and a mid drive. So that was all. We have discussed about the motors today, the types of the motors used in different types of the vehicles, and what we have not gone very detailed into the description of the motor, because that you all know that that is a very vast subject, and we have kept it precise and concentrated on the use in the electrical vehicles only. We have one more session, we will be discussing more in details about the electrical vehicle motors. And now any one of you, if you have any query, then you can either put it in the chat box or you can raise your hands.
Hello, sir.
I will take 2 minutes break. So Uday, if you can hold for 2 minutes, okay?
Yeah, it's okay, sir.
Yeah, sorry guys. Yes, Uday, please go ahead with your question.
Sir, you have explained about Hall effect of sensors now.
Yeah.
So can you explain once again, sir, like what factors that will sense from the motor?
So see, precisely, first of all, what is the role of the Hall effect sensor? So normal Hall effect sensors, what they do, they are like electronic transistors. What they do is they sense magnetic field, the intensity of the magnetic field and the direction of the magnetic field. Okay, that is only like the input that they receive. Accordingly, what they will do, they will change this into like a voltage signal, 0 to 5 volt, and this then they will give the signal to the controller. So this is like normal function of a Hall effect sensor. You get a Hall effect sensor also in your throttle. Also you have a Hall effect sensor. So they are first of all they are used for coordination between the motor and your controller. Okay, so now how they work. So as I said that if you talk about a normal motor, you have a like permanent magnets you have, and at the same time you are powering the stator windings through DC power only. Okay, so both the fields would be unidirectional. Okay, they won't be changing as we have in like in AC, that the field is changing. Okay, so at every instant, because they are in the form of the waveform, so they would be changing their direction. So but if both are DC, what would happen is after some time they would tend to move in a particular position. They will tend to come in parallel. Okay, so repulsion will not be there and they will start attracting each other. Okay, so in order to avoid this, what is done is there are three coils, as I mentioned. There the motors use three coil windings. They use these Hall effect sensors will be acting as a commutator, mechanical commutator, that we used in our earlier motor. So this would be an electronic commutator. So they would be supplying they would be powering one coil at a time, and then at next instant they will be powering second coil, then next instant third coil. So this would be happening very fast. This would be like switching would be happening very fast, and so that at every point of time these the permanent field, the field from the permanent magnets and this induced field in the magnetic winding keep on opposing each other, so that the motor keep on rotating.
So So like this permanent magnet motor, like the windings will be in rotor part.
No,
So
no, outer part will contain only the magnets. They will contain the windings would be on the stator part.
okay. So just to like if in AC it will be automatically reverse the polarity, but in DC that is not possible.
Yeah, yeah,
So
yeah.
that
So
for
since
that
there are
reason,
since there are permanent magnets, so that field intensity and direction would be always uniform. Okay, always same. Since on the rotor we have permanent magnets, so their direction of field and their intensity will be same at every point of time, because we are not changing that. Those are permanent magnets. Okay, so this
yeah,
field that is induced and the at a particular polarity that is induced in the windings of the stator, this would be, we have to change this so that these two fields don't align at any point of time.
okay, sir, got it, sir.
There is always a repulsion maintained. Otherwise, what will happen if they start attracting each other? Then we know that after some time our motor will lose its velocity and it will start coming at a position of rest. So instead that they keep on repelling each other, we have to energize or switch the power to the powering to the these coils would be done at one instant at a time. So this would be happening very fast. So not like we are discussing over here, it would be very happening very fast. So this is like a kind of commutator that we were using in the like this brushed DC motor that we were using.
Yeah, okay, sir.
Okay, any more queries, guys? So Bontha Ramesh has asked why hub motors use only two-wheelers. So Ramesh, to be to be very precise, first of all, in four-wheelers, since there are two drive wheels, so with single hub motor also, if we installed in one of the wheel, then controlling and the controlling would be a bit different, and which could like affect. And if we use two hub motors, then synchronizing these two motors would be an issue. So normally, since in two wheelers there is only a one drive wheel is there, so rear wheel is normally a drive wheel. So we use hub motors. Normally in two wheelers we use hub motors. Even not this, its use is also only restricted to two wheelers. There has been some experiments with the use in three wheelers, but has not become very very attractive till now. So since two wheelers have only one drive wheel, so we are using normally we are using in two wheelers. Further, you want to ask Ramesh anything, you can unmute and you can ask. Ramesh, have I clarified your doubt, or you want to ask or ask something more? Then you can unmute and you can ask it, or you can type in the chat box. Other students, if please ask if you have any query. So Mohan has raised his hand.
Good evening, sir. What is the difference between brushless DC motor and normal DC motor, sir?
So, Mohan, there are like DC motors are categorized in brushed DC motor and brushless DC motors. Okay. So, in case of brushed DC motor, what we are doing, what we are using two carbon brushes. Okay.
Okay,
and,
sir.
And a commutator is installed in that, so that this the DC the power that we are giving to the motor is reversed. Okay, at some instant, at every instant it is changed. Okay, for which we are using the carbon brushes and the commutator we are using to maintain the supply to maintain in a particular direction. But in case of brushless, we are not using this brushes, but we are using these sensors. We are using Hall effect sensors. We are using to change the change the powering of coils one at a time.
Okay, sir. Got it.
So Sai, Teja has asked, sir, hub motor fully covered. What about cooling off an motor while long drive? So hub motor as such, the temperature could be maintained because it is covered. Definitely it is covered, because but there is a lot of air that is flowing across it. So the temperature, it can withstand up to 60-70 degrees centigrade. It can withstand up to that. And it is like robust enough to take care of long drives also. So, but we should not be overheating it with until and unless it is not overburdened with loading more than the specific. Then it will start loading and heating, and that could damage the magnets in a long run. So we should take care that we are not like overloading our vehicle. Okay, so if we are like even for a long drives, if we are not loading the vehicle than the prescribed, then it won't be an issue. Like heating won't be an issue. It will be always like the motor would be more heated when it is extracting more current, and that will happen when we are overloading the vehicle. Lakhan has asked, sir, can you explain about switch reluctance motor and its use in EV? So Lakhan, this topic we are keeping it for tomorrow because we have another session for motor. So we will be discussing in that. Because there we have this topic. So we will be discussing in that. Tomorrow, in fact, on Friday, sorry, next session.
Hello.
Yeah, Arvind, hello.
Hi, sir.
Hi.
My question is very simple. In
Yes,
motors,
go
we
ahead.
use copper coil, right, sir?
Yeah.
On the capacity of motor, will the copper coil thickness and number of rotations decided?
Can you speak, can you repeat your question?
In motors, we use copper coil, right? We'll
Yeah,
use
yeah.
copper as a binding or
Yeah,
binding.
conductor we use as for
Yeah.
winding. Yeah, we use copper coils. Yes.
Yeah. On the capacity of motor, say let us
Yeah.
take 1 kilowatt motor we are taking.
Right.
In that, the what will say thickness of the copper wire and the
Yeah.
number of tons the copper coil should be for 1 kilowatt motor
Yeah.
will be included
Definitely.
or not?
Definitely. See, if you talk, say if you consider there is two motors, both 8 inches motor, or sorry, 10 inches motor are there, two hub motors are there. Okay, but one is of like 1 kilowatt and another is of 2 kilowatt. So the size is same, or simply the structure, the volume of the motor is same. So there definitely this the SWG that we call the standard wire gauge of a coil that we call, so that would be different. In case of higher capacity, the thickness would be higher because more current would be flowing through it. Okay, because we can overload it up to 2 kilowatt, whereas the another motor we can load it over to only to 1 kilowatt. So definitely these the thickness of the wire will be dominating depending upon the capacity of the motor. So this wire gauge, standard wire gauge that we are talking about, will keep on raising as the capacity of the motor will also increase.
Okay. Can you say what must be the thickness of 1 kilowatt motor, sir? Copper
So
wire.
this like the copper wire are normally available these copper wire, if you talk about, these are generally like proper insulated copper wires are there. So there is a proper high temperature insulation is there over the copper wire. So that when we are winding it, these two wires don't touch each other. Okay. So there are insulation, and then there is the varnish we do it so that the insulation between two turns is maintained. So they come from the manufacturer, they come into standard wire gauges only they come. Okay, there are set of wire gauges that they are available, 10, 12, 13, 10, 12, 14, in those wire gauges they are available. So we have to, depending upon the availability, we have to take it. Say if some wire gauges are like of less thickness, and if we have to make a strong magnets, we would be increasing the number of the turn. So in that way, we would be managing this.
Okay. Also, you shown one up motor of e-oxygen company, which is using in their vehicles.
Yeah. Yeah.
Is that up motor made by e-oxygen company itself?
No, it's as I clarified
imported?
Also, we have not manufactured that motor, but the re-engineered vehicle that we have made, we have used this motor. Okay. So it's not manufactured by us. There are very limited manufacturers. If you talk about in India, if you talk about, one is in Coimbatore. If you can research it yourself on the Google. One is in Coimbatore. Then there are other manufacturers who are developing the drive
motors
for the vehicle that they are developing. So there are different are there, but very limited, 4 or 5 only. And they are also very precisely speaking, they are also assembler at the end of the day, because magnets, as I said, that we don't have own deposits of these vanadium material, the rare earth magnets that we are producing. So we are dependent on other countries for importing these magnets. Okay, so they would be available either in the flat format, they would be in the flat either flat magnets, or they would be in the curved form. So we have to import those when we are so we are again assembler of motors, but definitely 100% indigenous motor, DC motor, we don't have any manufacturer. That is why we want to reduce this dependence on these magnets, and we are preferring that in electrical four-wheelers and other passenger vehicles, we use more and more induction motors, because in induction motor there is no permanent magnets, but we have electromagnets. So we are developing magnetics, we are inducing developing through electromagnets, the motor is performing. We don't have any permanent magnet in that. So the motive is that in bigger vehicles we use more and more induction motors, so that this dependency on magnets can be reduced on other countries.
It is the same situation with other startups also, sir. They are also importing motors from other countries, or else they are making their own.
Definitely. If you talk about DC motors, if you talk about any vehicle which is using a DC motor, DC motor primarily contains some magnet. Okay, permanent magnets, if it would contain. Okay, so that can be either a ferrite magnet or a rare earth magnet. So ferrite magnet, if you talk about the power capacity, or the power intensity, if you talk about the ferrite magnet, is very low. Okay, but that in case of electrical vehicles, from a small piece of motor, we want to have 1 kilowatt or 2 kilowatt of power extracted from it. So for that, the permanent magnets have to be very, very strong, very, very precise. Okay, so there we can use these permanent magnets, can be only rare earth magnets only. So if we use ferrite magnets, our motor size would be 4 times than what we have to do. So if we want to design a 1 kilowatt motor through these ferrite normal magnets, then the size would be 4 or 5 times bigger than normal magnets. It would be much bulkier, much heavier, and at the same time, these ferrite magnets, even with higher, they can't withstand very high temperatures, so they would lose their properties, whereas these rare earth magnets can stand to high temperatures, much higher temperatures than them. That is why in a small with very limited use, and with in limited space, we can have a motor, more powerful motor we can design with the help of these rare earth magnets. So anyone who is using these DC motors, they are definitely in one or the other way, they are dependent upon imports only.
Imports, okay. Sir, if you are making any vehicle on your own,
yeah,
which motor you are going to use, hub motor or a mid-drive motor in BLDC?
So if you talk about me, I would be preferring any day. I would be preferring the mid drive motor.
Why, sir?
See, first of all, initially, if as I said, that speed control is better. Initial speed control.
Okay.
Okay. When you are starting your vehicle, that is better. Then looking at the condition of the Indian roads, in southern part of the India, you know, like how much, what kind of rainfall issues we are facing in Bangalore and everything. So even if Hub Motors manufacturer is claiming that it is 100% waterproof, no water will enter into it, everything. But then also, if I am using this mid-drive motor, my motor is very much like up to a feet of water, it is safe. So that is second important thing for me. Okay.
Okay. Sir,
So
if not BLDC motor, which
yeah,
is the other motor you are going to use, PMSM or induction motor?
then I will be using BLDC motor. If I have to keep my if I have a proper particular budget, then for maintaining that budget, I will be using BLDC motor. If I don't have a budget constraint, then I will be using permanent magnet synchronous motor.
Okay. Then preferring to induction motor, you are going to prefer permanent magnet synchronous motor.
Yeah, but because in two-wheelers, I don't have this provision of using induction motor. Okay, because I cannot accommodate a induction motor, because again I will have to have an inverter installed. Okay, so all those will not be, like, design wise also will not be permitting me, and cost wise also it won't be permitting me.
Okay. Okay, sir.
So
Thank you.
as an engineer, as a technocrat, whenever you are designing a vehicle, whenever you are giving any design, anything, always keep in mind that it should be within the budget. What thing you are trying to create, because you can't create something that is not sellable. Always your product has to be sellable in the market. Okay, so you have to always keep in mind the budget and what are the
Okay.
preferences, what market needs.
Okay. Okay, sir. Thank you.
Sir. Hello.
Yeah, Uday, hi.
So you have discussed about SWG of wires, right?
Yeah.
So what is the highest SWG we are using in motors, sir? And what is the lowest?
See, this again depends upon the manufacturer. You will, you can research it. You will get all the SWGs available. Say one Bharti Bijli is there, who are the manufacturing of these conductors. Okay, so you research it. This can be a kind of a home for you. Research it. You will find that what is the lowest this SWG that is available. Best SWG is available. See, what happens is up to an extent, up to a particular voltage, to a particular capacity motor, we can use wire gauge. Happens if when the voltage increases and the capacity of the motor increases, tend to use the flats instead of these wire gauges, because they can take current up to an extent. Okay, after that what happens, they would be heating much, and they would be affecting the insulation of the wire. So up to a certain power only we can use this coils we can use. After that we had to use flats. So if you talk about a bigger generator side in the range of 1 megawatt and all those, so instead of wires won't be used there in the winding, you won't find the wires, but you would be finding these flats. Sense, like you would be finding kind of bus bars you would be finding. Okay, so through them the winding would be done.
So sir, you have said flats now. So those are like a
Yeah.
copper flats.
Yeah, so bus bars you have seen, the copper bus bars you have seen.
Yes, I have seen this copper flat.
Yeah, copper flats, you can see, we call normally in language, we would call them bus bars, like copper bus bars. So they are bars,
Okay.
copper bars, they are there. So they are installed for earthing. You must have seen GI bars, you would have seen, or copper in the same way the copper bars are also available. So they would be winding.
So for that, if I use a copper bar, then it will be not insulated, na? The copper bar will be not insulated, na? It will be
no, that they would be insulated, or I would be using accordingly I would be using, so that they don't touch each other. There would be a proper insulation on the bars.
Okay. If that is a copper bar, then definitely there will be interlayer insulation,
There would be an insulation. They would be properly placed in such a way that they are insulated from each other. Coils are insulated from each other. They don't touch each other.
So if I use a copper plate, then I will use some maintain a gap.
Yeah, maintain a gap, or you would, you maintain, because see, in if there are no much vibration, and if your motor is stationary, say in case, normally this case I'm telling you, it is more normally for generators, okay, for bigger generators, okay, because motors normally in 200 more than 200 300 watt of for more than 100 HP or 150 HP, you won't be finding more. But in case of generators which are in the range of megawatts, okay, so there you would be using the flats. So since the motion is stationary and no much vibrations are there, so they could be like placed in such a way that they don't touch each other. So accordingly, you can maintain them.
Yeah. Okay, sir. Thank you.
So Saintija, sir, any issues driving EVs in rain, like explosion or anything else? So Saintija, no, there are no such issues. Like everything is properly insulated. The connections or everything is like water resistance. Battery is IP67, motor is IP67, so that water doesn't enter into it. But then also, like in heavy rains and where there are stagnant waters, say more than a half a feet, you should be avoid taking your vehicles into that. But no, as such, no explosion situation until and unless the terminals of the battery short, and that also, if it happens, then there are protection in the BMS which will take care of it, and it will insulate the battery, it would separate the battery, it would disconnect the battery from the vehicle. So explosion will only happen if there are thermal stresses that develops in the battery, and there is in a sense, if the temperature goes beyond a certain limit and start affecting the cells, then only there would be an explosion. Other queries, guys, if anyone want to ask anything? See, this motor is a like very like wide field, because you all know that they are being used at different not only in the industry, and now their use has been become like very more popular in the mobility sector, automobiles, by the coming of the electrical vehicles. Otherwise, their use is like very wide in the industry. Any type of industry you go into, any kind of machine you talk about, you would have a motor, one or the other kind of the motor. Even in the entire robotics, that is dependent upon the motors only. The movement of the robots or any process, if it is done through the robots, they also use different types of motors they use. So it's a very vast subject. Anyone else, anyone want to ask any query, please, guys? Sir, can we stop power input after fully charged? So there is a provision, like Saintija, there is a provision like when once fully charged, the BMS will cut off the charger from the battery, and it won't allow the battery to it won't accept much power, and will not be the charger won't be pushing in power after that if it has been fully charged. So BMS will take care of that. If fully charged, it will disconnect the charger. It will not accept further charging. So safely, like even overnight also, if you leave out, there is not an issue. See, Arvind, you have asked how far should the new startups focus on the EV motors. See, first of all, most of the startups, they normally focus on the software part of any vehicle. Okay. So this is, if you talk about the motors, definitely they can come up with a, like, even if not with a commercial manufacturing, but definitely they can focus on increasing the reliability, increasing the efficiency of the motor. They can focus on that, and definitely the use of the material which is like in-house available, which we can manufacture indigenously. We can manufacture motors, so that could be definitely done in the EV motors. So this is also a huge subject of research for automobiles. If you talk about, mostly people are working on the battery or the software part or the controller or the electronics part they are working, but motor is very highly neglected. Very few startups are working on the EV motors. Anyone else want to ask any further queries, guys? Please go ahead.
I think Govindji, that's it. I think there's no very new.
Yes, sir. One more, like Lakhan has asked something. Sir, in four-wheelers, how many induction motors? One of it fails, what will be the situation? So Lakhan, normally we maintain only a single induction motor only, because like if you talk about an electrical four-wheeler, it would be like in the like starting from 15 kilowatt to 25 kilowatt. It would be like normally car, if you talk about, that would be the motor capacity, and you can imagine the size of the motor also. So only one is advisable, always one is advisable to use. And in case of breakdown of the motor, see, normally motors are the last to break down. They only in very extreme situations only they will break down. The failures of the motor is very rare. Okay, so no vehicle would be maintaining a second motor. So if there is any failure, so but they have to attend it, like either they have to tow the vehicle and take it to the service station and they have to rectify it. But again, I am repeating my statement that motors are very rare to fail. Even in the industry, if you talk about, the motors won't be failing very easily. If you hear the cases of motor being burnt, that are because of our negligence only, because of our not better if we are overloading the motors and continuous overloading, they can take to an extent 20% of overloading of the motor is also they are available. Continuous 20% over motors are designed in such a way that they can take 20% higher overloading also. But if the situation continues for a very longer time and very extremely exposed, then only the motor will break down. Otherwise, it is a very reliable component. Sir, if I need to get job in e-oxygen or any other EV companies, in what sector should I need to focus? So Arvind, like I will not answer your question over here, but definitely when Sujoy sir and Mark sir and the team would be coming to Hyderabad, you can definitely meet them in person and they would be giving you the best of the advice, to be very frank. Okay. So if we can focus here more on the questions related to the topics, that would be good. Otherwise, you would be getting a good window to interact with them. And I think only on 10th only we are doing it. So after 3-4 days, you can interact with them and they would be giving you the best of the career solution and career advice you can have. So there you can definitely interact with them regarding this. Okay, Arvind?
Okay, so okay.
Okay. So you would have a good window, you discuss about them. They would be working on your overall improvement. They would be discussing with you in person. Every student, they would be discussing in person and you will definitely get a solution out of it. Okay.
Okay, sure. Thank you.
Yeah. So Renuka, should we I think we are done with the queries. So yes. Should we call it a day today?
Yes, sir, definitely. We'll just to closing today. Okay.
Yeah.
And thank you, Govind sir, and thank you, Navan sir. Thank you, students, for everyone for participation in this session. Thank you, sir.
Thank you, everyone. Thank you, all the students. Thank you, Nabangshuji. Thank you, Renuka. And we look forward to the next session on Friday. Thank you, everyone.